This is the Physics Standard Level Paper 2 question, Time Zone 2, May 2010. And we have our first question, A1. We have our data analysis question. So it says, Gillian carried out an experiment to investigate the craters formed when steel balls are dropped into sand. To try and find out the relationship between the diameter of the crater and the energy of impact of steel balls of the same diameter, she dropped a steel ball from different heights h into the sand and measured the resulting diameter d of the crater. The data are shown plotted below. So this is your direct data. We have our independent variable, we have our height from which you dropped it, and our dependent variable, our diameter. We have a multiplier here, 10 to the minus 2 meters. So the uncertainty in the measurement of d is plus minus 0.40 centimeters. The uncertainty in h is too small to be shown. Draw an error bar for the data points 0, 2, 0.047 and 2, 0.10. So we need to put in our error bars, and our error is plus minus 0.40 centimeters. So here we have this is measured in meters and is 10 to the minus 2. So we can see that this is going to be plus minus 0.4 times 10 to the minus 2 meters. Because the centimeters, when you convert the centimeters into the meters, we multiply by 10 to the minus 2. So basically we've got to put in an error bar here of plus 0.4. Now in looking at this, we see we've got 5 spaces here, 5 spaces, and that goes from 1 to 2. So each of these would actually be 0.4. So it's going to be a 1 block space on either side for each value. So we have the first one is at, we need to do this at 0.2. So that is this one over here, that's 0.1, 0.2. So we've got to do one. Now it's not so easy for me to do it, you'll be able to do it much better, but you need to be 1 block on either side there. And you need to be able to look at that. And then we also want to do it for 2, which is this one over here. So again, 1 block on either side. We would measure that. Okay. Alright, so that should be fine. Then it says draw a best line fit. Now, when it says best line fit, it doesn't have to be a straight line. It's the best line that will go through. And I think you can see that a straight line wouldn't go through all of these points. The best line fit would actually be a curve for this. Now you need to make sure that your curve goes through these error bars and that you extend it through. So you'll draw something like that. Make sure that you extend it through your y-axis. Alright, is that okay? Then going on to C. The original hypothesis made by Gillian was that the diameter of the crater is directly proportional to the energy of impact of the steel ball. Explain why the data does not support this hypothesis. So we have our energy of impact, firstly, when she says is directly proportional. Now we know that the energy of impact will come from our potential energy. So we get EP is equal to mgh. So we're going to have that the diameter is going to be proportional to the EP, and therefore by this, because m and g are constants proportional to h. So if you've got a direct proportion graph, we would be expecting a straight line through the origin. So because this line is a curve, because it's a curve, and because it doesn't go through the origin, because it does not go through the origin, the hypothesis is not supported. Okay. So you need to explain this. You need to explain what it means when it says it's proportional. You need to explain why the potential energy is proportional to the h, and therefore the diameter is proportional to the h. Why that would indicate that your potential energy, your total energy, is also proportional to the h. Good. Going over the page, we're now over here. It says over here, since Gillian's data did not support her hypothesis, she researched to find alternative hypotheses. She found that there are two theories used to predict a relationship between D and H. In order to find which theory is best supported by the data, she processed the data in two separate ways. The processed data are shown below. So we have here that she said that D is basically proportional to H to the half, and here she had D is proportional to H to the quarter, like that. Draw a best line, a best fit on each of the graphs. Now here you need to use a ruler. You can see here that it's possible for a straight line. You need to use a ruler, and I'm not going to use a ruler. It's difficult for me on the board to use a ruler, but you need to try and draw it so that it goes through the origin if you are wanting to support, because this over here would be that you'd want a line going through the origin and going through the error bar. So you'd want to see if that was possible to do that. Now here, if you look at this, it's not possible to draw a line through the origin and also through let me do that again. That's pretty poor. I'm not very good with this. So it's through the origin. If you draw that, you can see you can go through all the points, but you are not going through the origin. So you could either draw it like that, or you could draw it something like that, through the origin, going through some of the points. Either way, you can't draw one that does both, going through all the error bars and also through the origin. So this one over here for question 2, state and explain which is best supported by the student's data. Well, obviously theory 1 is best supported because you can draw a straight line. It's possible to draw a straight line through the origin, through 0, 0 point, and also through all the error bars. Right, and there we have it.